Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is the last part where I will be solving last few problems on the standard result on the standard exponential result of limits, which is limit of a to the power fx minus 1 divided by fx when fx tending to 0. This is equal to log a to the base e, where a is a constant greater than 0 and not equals to 1. This video is part of the playlist Problematic Mathematics for class 11, where I primarily discuss about the key concepts and formulas that will help you to solve problems that comes in competitive examinations like JEE Mains, JEE Advanced and WBJEE. If you find this video beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Okay, so the standard result that we will apply to solve this problem is this limit of a to the power fx minus 1 divided by fx. This is an exponential standard result where fx tending to 0, which means that whatever the tending value of x is, for that tending value of x, fx must tend to 0. The answer is, the result is log a to the base e. But remember that the constant a is greater than 0 and not equals to 1. Okay, the first problem is, it looks complicated, but you can clearly see. Okay, so it is limit extends to extending to infinity, and we have 2 to the power, the power is x to the power n. Now clearly we can see that we can simplify what is happening. We can simplify the power of 2 and 3. So it will be limit x tending to infinity. We can clearly simplify the power of 2 and 3, and it will be 2 to the power x to the power n divided by e to the power x minus 3. So power of 2 is x to the power n divided by e to the power x. Similarly, power of 3 is x to the power n divided by e to the power x, and we have divided by x to the power n. Okay, so n is a natural number given. Now we see that clearly it looks similar like a to the power x minus 1, a to the power x, where a is, we have two terms, exponential terms, where one base is 2 and another base is 3, and they are all greater than 0 and not equals to 1. But the power is x to the power n, which is a function of s, of course. Now let's see what happens to this. What is the limiting value of x to the power n divided by e to the power x when x is tending to infinity? When x tends to infinity, x to the power n, since n is a natural number, will tend to infinity, and e to the power x will also tend to infinity. It will also tend to infinity. Okay. The power 3. Now, in the denominator we have x to the power n, x to the power n, but this, what will be the limiting value of x to the power n divided by e to the power x when x is tending to infinity? We first need to investigate this. X tending to infinity implies that x to the power n will also tend to infinity, where n is a natural number. Also e to the power x will also tend to infinity. So x to the power n divided by e to the power x is of the form infinity by infinity. It is of the form infinity by infinity. Now can we apply L'Hopital's rule? I mean, the core objective was to solve this problem using the standard result, this one, but eventually we are ending up in using L'Hopital's rule. That is fine, because in solving a limiting problem, it is obvious that you have to apply a lot of various methods and various concepts and standard results to solve a limiting problem. Now L'Hopital's rule. Now if I keep on if I differentiate x to the power n, it will not end. It should end because n is eventually a natural number. In the denominator we will always have e to the power x. 0 e to the power x. E to the power x. Okay. N is a natural number. X is tending to infinity. X is tending to infinity. Okay. Now sometimes the expansion series of e to the power x will also very, very handy. Let me see. E to the power x and e to the power x over x. So e to the power x is the series expansion. The expansion series of e to the power x is, if I am not wrong, 1 plus x square by 2 factorial plus xs cube by 3 factorial. It's an infinite series. Okay. Now what will be then? X to the power n divided by e to the power x. This will be x to the power n divided by 1 plus 1 plus x xs square by 2 factorial plus xs cube by 3 factorial. This will go on. Okay. Now n is a natural number. It should not be a large natural number. Now x is a natural number. Okay. Okay. Now so this is, this becomes, if I divide both the denominator and the numerator with x to the power n, I have 1 by x to the power n plus 1 by x to the power n minus 1 plus 1 by 2 factorial x to the power n minus 2. Okay, and it will go on. It will go on. Possibly when so in the expansion series of x, e to the power x, somewhere we will have x to the power n divided by n factorial. Okay, so I have then there will be two. Okay, so somewhere it will be x to the power n. So this will be n factorial, and I will have x to the power n minus n and then again I will have, it will go on. Okay, so at one point when in the expansion series of e to the power x, somewhere it will be x to the power n divided by n factorial. Now as x is tending to infinity, all these terms will be tending to 0. All these terms will be tending to 0. So we will have something like, so limit x tending to 0, x to the power n divided by e to the power x, it will be something like, these are all tending to 0, tending to 0, tending to 0. Somewhere there will be 1 by n factorial, and then infinity, infinity, infinity. N is a natural number. No. Still the denominator will be infinity. Still the denominator will tend to infinity when x is tending to infinity. No, I don't think I will be able to properly use the expansion series of e to the power x. X to the power n divided by e to the power x. What will be the limiting value when x is tending to infinity? N is a natural number. 0. So I think somewhere down the line in the denominator it will be tending to infinity, infinity, infinity. So this is actually becoming 1 by infinity. Okay, I see. This is actually tending to 1 by infinity, which is tending to 0. Okay. So I think limit x tends to infinity, x to the power n divided by e to the power x is tending to 0. Then only it will make sense. Okay. It is tending to 0. So I am quite sure this is a result that when x tending to infinity, x to the power n divided by e to the power x, where n is a natural number, this will be equal to 0, because I think the growth of e to the power x is much larger than x to the power n. Okay, so considering this to be true, that is limit of x tends to infinity, limiting value of x to the power n divided by e to the power x when x tends to infinity, it is tending to 0. It is tending to 0. Okay, then what will I do is I will now x to the power n, I will put an e to the power x over here and I will adjust e to the power x, and then I will, let's say, substitute x to the power n by e to the power x as h. This is n, x to the power n. Then the limit becomes, if then the limit, so this will imply that h tend to 0 as x tend to infinity, because we have I think it's a known result that limit when x tends to infinity, limiting value of x to the power n divided by e to the power x, where n is a natural number tending to 0. So we have this. So we can write the limit as limit h tends to 0, and then 2 to the power h minus 3 to the power h divided by h and e to the power x. So what will be e to the power x? E to the power x, e to the power x, we are left with e to the power x. We are left with e to the power x. Now I have to convert all the limits in terms of h. X to the power n by divided by e to the power x, we have assumed to be h. So what will be e to the power x? So e to the power x is equal to x to the power n divided by h. So when x is tending to infinity, 0. Okay, so clearly e to the power x, it will obviously tend to infinity when x is tend to infinity. Okay. Now see one thing that okay, now okay, so we have done this substitution. Now see one thing that this limiting value, if I if I consider the limiting value of this, that is after substitution of h, after if I consider for the let's say just for the sake of discussion, let's say just for the sake of easiness of solving, let x to the power n divided x to the power n divided by e to the power x, I am calling it as fx. So the limit is now, of course, fx will tend to 0 if x tends to infinity, fx tending to 0, and I have 2 to the power fx minus 3 to the power fx divided by, I have fx and I have e to the power x. Now if you ignore the e to the power x in the denominator, you will see that the limiting value of this thing, the limiting value of this part will be a finite value, because what will be this? If you see that limiting value fx tending to 0, I have already solved this kind of problem in previous videos. This will be a finite value. This is, I can take, I will factor out 3 to the power fx from the numerator. So this will be 2 by 3 to the power fx minus 1 divided by fx. I have taken common 3 to the power fx from the numerator. So this is nothing but 3 to the power fx, when fx tending to 0 it will be 1. So this is nothing but log 2 by 3 to the base e, using the standard result, that is a to the power fx minus 1 divided by fx when fx tending to 0 is log of a. So this is a finite value. Now, so this limit I can say is now becomes limit, it becomes now log 2 by 3 to the base e multiplied by limit fx tending to 0, which fx is nothing but x to the power n divided by e to the power x. We can still say that x is tending to infinity and 1 by e to the power x. So this is nothing, limit x tends to infinity, 1 by e to the power x is 0, because it is 1 by infinity and it will be 0. So this is 0. So the answer is 0. The important thing to understand and realize was that limit x tends to infinity, x to the power n divided by e to the power x is always equal to 0 for n is a natural number. This is an important result that you must always know. Okay, let's see the next problem. Okay, limit x tends to 0 and the entire function is inside a box, that is greatest integer function, and we have inside the box 1 minus e to the power x multiplied by sin x divided by mod of x. Now remember that limit x tends to a, whatever a be, box of fx is always equal to box of limit x tends to a fx. We will apply this concept. This is basically a very simple algebraic formula on limits. Okay, so basically let's find out what is limit, and then we will put the result in a box. So limit 1 minus e to the power x sin x divided by mod x. We have to find this limit, and whatever the result will be, let's say this is capital L, the final result will be box of L. Okay, now I see 1 minus e to the power x, 1 minus e to the power x. Okay, so let's rearrange it and I put a negative sign outside. This is limit x tending to 0 e to the power x minus 1, and I have sin x and mod of x. Now to apply the standard result of e to the power x, remember that based on the standard result we know that limit x tending to 0 e to the power x minus 1 divided by x is equal to log e, which is equal to 1. So I will create the standard result. What will I do? I will put a x over here and I will adjust x. Okay, now so this becomes negative of limit x tends to 0 e to the power x minus 1 divided by x. Its value is 1. So this becomes limit x tends to 0 sin x divided by mod x multiplied by x. Now mod x multiplied by x. Okay, now we have to be a little careful over here. I think we have to investigate whether mod x, now when x tending to 0, when x tending to 0, minus 1 mod of x. Okay. So x is tending to 0. So mod of x will be definitely 0 positive, but will be 0 positive, and sin x let's see. I think the value of this limit will be 0, will be limiting value will be 0, negative of 0, Now limit x tends to 0 sin x multiplied by x divided by mod x. Now okay, I think we have to investigate the now what will be limit x tends to 0 sin x is 0. Limiting value of sin x when x tending to 0 is 0. It is 0. It will depend. I mean, it will be 0 positive when x tends to 0 positive, and it will be 0 negative when x tends to 0 negative. Let's see what will be x tending to 0 positive sin x we have divided by mod x by x. When x is tending to 0 positive, it is 0 positive, then this will be limit x tending to 0 positive sin x divided by mod x can be written as x, because x is positive, that is 0 positive means x is greater than 0. So this will be x by x, which is equal to limit x tending to 0 positive sin x, which is equal to 0 positive. 0 positive, okay. 0 positive, okay. So in that case we have a negative, So this will become okay. Now let's see what will be the limiting value when x is 0 negative. When x is 0 negative, then sin x mod x will be open as minus x by x. So this is limit x tending to 0 minus negative of sin x, but since when x tending to 0 negative, limiting value of sin x when x tending to 0 negative, it will be 0 negative. So negative of 0 negative, which is basically 0 positive. So this is coming out to be negative of 0 positive. Negative of 0 positive, which essentially means 0 negative. So we are having L is equal to 0 negative. So obviously if I take box of L, it will be box of 0 negative, we know is always equals to minus 1. Okay. This problem, I think we have to find the value of alpha such that limit the limit when x tending to 0, we are given the function is equal to 3 by 2. Now obviously this is very easy if you use L'Hopital's rule, because clearly we can see it is of the form 0 by 0. Now I think it will be a very bad idea if I try to solve this problem using the standard result, exponential standard result of a to the power alpha x minus 1 divided by fx is equal to log a. I will not solve this problem because it can be easily solved with L'Hopital's rule. Let's try to solve it using the L'Hopital's rule. So this is of the form, clearly we can see 0 by 0. I will discuss about L'Hopital's rule definitely in some future video. But let's anyway quickly solve this problem using L'Hopital's rule. So this will be limit x tending to 0. If I differentiate the numerator, we have alpha e to the power alpha x minus e to the power x minus 1 divided by twice x. Okay, still we can see it is still of the form 0 by 0. 0 by 0 form, that is tending to 0 divided by tending to 0 form. This is an indeterminate form. Is it? No. E to the power sorry, this is not indeterminate form. Now it is given. Now in the denominator we see, so this is an important concept. In the denominator, if we put x tending to 0, we have 2x, it will be 0. But in the numerator, what is numerator? It is becoming, so if I substitute x tending to 0, what limiting value we are having? We are having alpha e to the power alpha x will become 1. So alpha minus 1 minus 1 divided by 2 into 0. So this is alpha minus 2 divided by 0. At this stage, after applying L'Hopital's rule once, we are having this. Now in the denominator we are having 0, and if I at this stage if I substitute the value of x as near to 0, we are having something alpha minus 2 divided by 0, which can only be solved only when the numerator will also be 0, because we are given the limiting value is 3 by 2. That is, it exists and it is finite. Now, so clearly we must say that alpha minus 2 should be 0. This implies alpha is equal to 2. Okay, let's see. Okay, let's solve this problem. So limit x tending to infinity, and we are having x into a to the power 1 by x minus 1. So clearly we can see that when x tends to infinity, x tending to infinity implies 1 by x is tending to 0. So this is limit x tending to infinity. We have a to the power 1 by x minus 1. Let's rewrite x as 1 by x. 1 by x. Now I can clearly do substitution, like let 1 by x is equal to h. This will imply h will tend to 0 as x tend to infinity. So the limit will become limit h tend to 0, a to the power h minus 1 divided by h, which is a direct, we can apply directly. This is the, we are having a direct, can apply the direct result of this, the standard result, and it is log a to the base e. Let's see this problem. We are having x tending to 2 sine of e to the power x minus 2 minus 1, okay, divided by log of x minus 1. Okay, I have sine, so clearly I can by intuition I should be able to, I must create the form sin x by x, and I also see that e to the power x minus 2 minus 1 is somewhat related to the standard result a to the power alpha x minus 1 divided by fx. So what will I do is, first of all, should we I think it will be a good idea if we do substitution x minus 2 as h. This will imply that h will tend to 0 as x is tending to 2. Then the limit will be limit h tends to 0 sine of e to the power h minus 1 divided by log of x minus 1. X minus 1 will be 1 plus h. Okay, so this is limit f h tends to 0 sine, we can see e to the power h minus 1, e to the power h minus 1 is tending to 0 when h tending to 0. So to apply the standard result that x tending to 0 sin x by x is equals to 1, I will create the x. Over here the x is e to the power h minus 1. So e to the power h minus 1, I will create it e to the power h minus 1, then I will have to adjust it e to the power h minus 1, and I have log of 1 plus h. This part will be 1 because e to the power h minus 1 is tending to 0 when h is tending to 0 when h is tending to 0. So this becomes now limit h tending to 0 e to the power h minus 1 divided by log of 1 plus h. Again I see e to the power h minus 1, I will bring an h in the denominator and I will adjust and also I see log of 1 plus h. There is another standard result that limit x tending to 0 log of 1 plus x divided by x is equal to 1. So e to the power h minus 1, I will create the h so that I can apply the standard result. I will adjust the h and I have log 1 plus h. So adding extra factors, extra terms, so that you can create a standard result and then adjusting it. This is a very powerful tool or strategy you must always try to apply in solving a limiting problem. Okay, so this now becomes limiting e to the power h minus 1 divided by h. When h tends to 0, the limiting value will be 1. So we now have limit, and also you see that h by log of 1 plus h, limiting value of h by log of 1 plus h when h tending to 0 is also 1. So this is 1 into 1. Basically the answer is 1. Answer is 1. Okay. Let's see if we can do this. e to the power x square minus cos x divided by x square, x tending to 0. Now possibly you can easily solve it using the L'Hopital's rule, but I am trying to see whether I can apply the standard result, that is a to the power alpha x minus 1 divided by fx when fx tending to 0 is log a. What can I do? If I e to the power x square, if I create a minus 1 and then adjust the 1, and I have cos x divided by x square. Sometimes this is also one strategy. If you have something like in the numerator, if you have something term like a to the power fx, and you do not have this minus 1, then you create a minus 1 and then you adjust. This is also one strategy that sometimes it may work. I think it will work in this problem. So this is limit x tending to 0. I can separate it out, e to the power x square minus 1 divided by x square, and I have plus limit x tending to 0 1 minus cos x divided by x square. Now 1 minus cos x will be 2 sin square x by 2. Now the first factor, this is 1, because fx over here, the fx is x square, which will tend to 0 when x is tending to 0. So this is 1 plus limiting value of x tending to 0, 1 minus cos x is 2 sin square x by 2 divided by x square. Okay, so I have 1 plus, clearly I can see that I will, for the second factor, this one, definitely I have to apply the concept of limit x tending to 0 sin x by x. That's standard result. But I have to create something and adjust. X tending to 0, let's bring the 2 outside. Sin square x by 2. Okay, sin square, I have sin square x by 2. So clearly I need as a denominator x by 2 whole square. X by 2 whole square. And then I will adjust x by 2 whole square. And in the denominator I already had x square. Okay. So this is 1 plus 2 times limit x tending to 0 sin square x by 2 divided by x by 2 whole square. The limiting value when x tending to 0 will be 1. So I am directly putting 1 and we are left with x square by 4. So I have 1 by 4. Okay, so this is equal to 1 plus a half, which is 3 by 2. I hope the answer is 3 by 2. Okay, 3 by 2. This one also, okay, this one, you see that in the denominator we are having x square. We are having x square. So now you might be tempted to write minus 2 as minus 1 and minus 1, and you will have e to the power x minus 1 plus e to the power minus x minus 1, but it won't help because in the denominator we have x square. So the thing is that so a lot of you have to do a lot of observations and try to think how you can re-express the given function so that you can easily express it in some form so that you can apply the standard result. Now e to the power x plus e to the power minus x minus 2, if I write it as e to the power x plus 1 by e to the power x minus 2 and then divided by x square. This is equal to limit x tending to 0. I have now, if I simplify the numerator, it will be e to the power twice x plus minus 2 e to the power x plus 1 divided by e to the power x, and I have x square. This is equal to e to the power x, limiting value of x limiting limit x tends to 0, and I have e to the power 2x minus 2 into e to the power x plus 1 is nothing but e to the power x minus 1 whole square, and the e to the power x in the denominator, it will become 1 when x tends to 0. So I am not writing it, we have x square. This is nothing but limit x tending to 0 e to the power x minus 1 by x whole square. So clearly the limiting value of e to the power x minus 1 divided by x when x tending to 0 is 1. So this will be equals to 1 square, which is 1. I think I will end the video here. The next, how many problems are left? The next few problems I will solve in another video. I hope solving these kind of problems will give you some idea how to apply the standard result, the standard result, this exponential standard result in a suitable way, and how first of all it is very crucial to understand that whether the given problem whether you can apply the standard result or not. For this you must see some term in the numerator like a to the power of x. A is a constant greater than 1 and not equals to greater than 0. I'm really sorry, this is not greater than 1, this is greater than, a is greater than 0 and not equals to 1. And if you see some kind of term a to the power of x minus 1 or even not minus 1, and in the denominator also it could be fx or it could be any other function but which is tending to 0, then possibly you can try to express the given function, rearrange it so that you can apply the standard result. So solving limiting problems is you have to it is always an application of multiple methods. First of all, you must be very aware of all the standard results. You must be aware of applying the L'Hopital's rule and the other methods of solving limiting problems like rationalization, and of course the exponential indeterminate forms and other indeterminate forms like infinity minus infinity and 0 into infinity. All those concepts you must have a good idea, then only you will be able to solve a limiting problem. In the next video I will solve the remaining 3 or 4 problems, and then I will start discussing about I think I will first discuss about all the standard results and their variants, because knowing the standard results is very, very important in solving limiting problems. So if this video was beneficial, then please like it, share it with your friends. Once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I am ending the video here. Thanks for watching, and until the next video, take care and bye.